plot the polar coordinate 3, pi over 2, then give two representations, one r less than 0, the other one r greater than 0. In polar coordinate, the point is represented by r, which is the radial coordinate, and theta, which is the angular coordinate. In this case, the radius is 3 and the angle is pi over 2. We can just simply graph it on the Cartesian coordinate system, which keep in mind that there are circular help lines in the polar coordinate. First, we measure the radius of r from the origin. R equals 3. 1, 2, 3. This will be the magnitude of the radial coordinates 3. We then rotate counterclockwise an angle of pi over 2. Pi over 2 is 90 degrees, which is a quadrantal angle. So we stop at the y-axis, but we need to stay on the circular help line of radius 3. So when we get to the y-axis, the distance from the origin should still be 3. We start at the positive horizontal axis and we end at the positive vertical axis. This time, at this point, the coordinate of this point in polar coordinates is the radial coordinate is 3 and the angle is pi over 2. By looking at this, we can see that in rectangular coordinate system, this point is represented by x equals 0 and y equals 3. Representation by polar coordinates is not unique. We can come up with infinitely many of these polar coordinates that will give us the same location, because we can go around and around this circular ray, clockwise or counterclockwise. To obtain another representation with negative radial coordinate, the easiest way is to locate another point that is in the opposite direction of the given point. When we say opposites, what we mean is in 180 degrees turns. So the opposite point to the point 3, pi over 2 should be in the negative vertical axis, and it should be 3 distance away from the origin at this point. The coordinate of this point, imagine for the moment that this given point wasn't there. How do we get to this point down here? To get to this point, one way to get there is to start from the positive horizontal axis and go clockwise. But if we go clockwise, then the angle is negative. In fact, this is negative pi over 2. And again, assume that it wasn't there. To get from the positive horizontal axis to the point down here, we just simply go an angle of negative pi over 2 with the radial coordinate of 3, because to get here, we didn't flip it. Now, to get the opposite point of the yellow point, we would need to flip this radial coordinates. So even though this is 3, negative pi over 2, if we flipped it, we would obtain negative 3, negative pi over 2. The only thing we did to get from this yellow point to this green point is to flip it. And the action of the flipped is the negation of the radial coordinate only. Negative pi over 2 stays. The point with the negative radial coordinate is negative 3, negative pi over 2. This is not unique. Another representation for the yellow point down here is r equals 3 and theta equals 3 pi over 2. To get there, we would simply go counterclockwise an angle of 3 pi over 2, and again, we didn't flip it, so r equals 3. Now, taking this point and flip it, we would obtain another point up here, which is negative 3, 3 pi over 2. And again, we didn't go clockwise. We went counterclockwise, so the angle is still 3 pi over 2. We flipped it, so the radial coordinate turns negative. So there are actually many representations. We can just pick any of these that satisfy the condition. In this case, there is no restriction on theta, so any of these will work as well, as long as the radial coordinate is negative. To obtain another point with the positive radial coordinate, one way to do this is to go another complete rotation. This is 3, comma. Initially, we get to this point, 3 comma pi over 2. We can go counterclockwise to maintain the positive radial coordinate, and we make one complete full rotation. But one complete rotation is 2 pi. This is 3 comma 5 pi over 2. And this polar coordinate has the positive radial coordinate, and it represents the same point.